first lesson we're going to take a look at here back from fall break is looking at a review of factoring quadratics. It's been a couple weeks, so I want to make sure we know how to do this. Factoring quadratics is a big thing, and it's still going to be here in polynomials, and so we're going to review this here. As a reminder, if I've got a quadratic, my first example is 6x squared minus 5x minus 25. My goal is to look for what are some possibilities that I have that could multiply together to get to that. I don't know what the answer is yet, but I want to be able to find if I have some options. I want to be able to use a guess and check process here. In order for us to do that, what we do is we look for our first two terms. That's going to be the first one in each set of parentheses, the one that's with the x. Those two need to multiply to my x squared term in my quadratic. So that's why I have a bunch of 2x's and 3x's. 2x times 3x is 6x squared. And so any option that has a 2x and a 3x will get me to 6x squared at the beginning. Now there is another possibility besides 2x and 3x. Pause your video right now and write down, besides just that possibility, what would the other possibility be for what could multiply to 6x squared? The last numbers in our set of parentheses here, the constant terms for each, so in this first one it's 1 and 25, those numbers come from, I have to have those two numbers multiply together to get to my last term, my negative 25. So what I'm looking for is possibilities that multiply to that. 1 and negative 25, since I'm multiplying to a negative 25. Positive 25 and negative 1. I can also do positive 5 and negative 5. And so while there might be more options up there than this, our goal is to find as many options as possible, because then I have a list, and it's just guess and check. It's multiple choice. And one of these should be my answer unless I didn't find it in the beginning. When we're doing our problems, my suggestion to you is to actually write down all of them that you can think of first. Don't go back and erase them, but write them all out first. That'll get us in the habit of, when we start factoring polynomials, I can use the same idea. We're writing down a list and just cross them off when I find out they don't work. To figure out if they do work, what I do is I go back through my FOIL method. Now my FOIL method is, first, outside, inside, and last. My first two, I already have determined my numbers so that they get to 6x squared, my first one. So they're all good. My last two, the 5 and the 5, the 1 and the 25, I've already set up so they get to 25, my last one. And so both of those are already good. What I'm looking for now is, what does my outside-inside pair get me? Because the answer should be negative 5. If it's not, that means that that set of parentheses is not the correct one. If it is, that means that it is, and it does work. So I multiply outside, inside. The first one, I've got negative 50x and positive 3x. That's a negative 47, and it's not our answer. The second one, I multiply outside and inside. I have a negative 2x and a positive 75x. That's going to add together to get to 73x, and that's even farther off. That's not our answer. The third one, I've got 5 and 2 to give me a negative 10x, a 5 and 3x to give me a 15x, and those will add together to get to a 5x, which is what I'm looking for. The only problem is that my answer is positive, and it should have been negative. A general rule when factoring this way is, if you get to the answer and you've got the wrong number, change around the numbers. If you have the wrong sign, if this is positive and it should be negative, change the signs. Change your 2x plus 5 into a 2x minus 5. Change your 3x minus 5 into a 3x plus 5. And then it will give you the negative 5 in the middle that you wanted. This is the factored version of your problem there. That will be how we find our answer in that first example. Now remember, what we want to do from here is we want to also be able to find what are these zeros, what actually gets us to the answer of all of this equals 0. Every problem will have where it wants you to find the factors, and then after that wants you to find the zeros. And so the way we do that is we set each of our parentheses separately equal to 0 at the same time and figure out what would solve these equations. We're solving them by using our regular reverse order of operations. Just get x by itself. And the first one, I add 5 and divide by 2. And I get 5 halves. In my second one, I subtract 3 and subtract 5, and divide by 3. And I get negative 5 thirds. And so on your worksheet, you're going to see problems that are, here's a quadratic, find the factors. And so your first step is to figure out what is the first and second factors going to be and write your answers in the parentheses. Second is being able to find what are the zeros, and that's by finding if x equals this number and x equals this number, that those are the zeros. And then third, we actually want to make sure we know what that means. And so our third step is to actually take each of these answers and plug them back into our original equation and actually verify by step, by actually going through and doing the math, evaluating it together, making sure it actually gets us to 0. The concept of what types of numbers can get us to 0 will be important when we start looking at polynomials, and so that's what we want to focus on. Our second example that we have is similar to that. I'm not going to go through the whole thing, but I will talk about what is one step that can make these problems easier if you look at it and there's a lot of possibilities and you're not sure what the answer is going to be. One thing we can do first is if we see that every number in this case is a multiple of 2, and in fact it is 6, negative 28, negative 10, one thing we can do first is we can get rid of and divide them all by 2. Now, if this is an equation, all of this equals 0, I'm allowed to divide both sides by the same thing. That's perfectly fine. We did it here. We divided both sides by 2. If this is just where I'm factoring, rather when I'm dividing by 2, I'm really undistributing or factoring out a 2. And so when I get my answer, yes, it's going to be 3x squared, 14x, and 5 when I divide all of those by 2, but I'm actually going to write the 2 on the outside there because I undid the distributive property to place the 2 on the outside. From there, I'm trying my different options. I'm seeing which one works. I've got a couple of possibilities that are up here. On your notes, pause this real quick and just look at what are the middle term going to give you and which one actually gets to be your answer, because one of those will work. Since I know some of us have struggled with factoring, what I also want to do is I want to talk about a new method to factor. Now, over break, I learned from, I taught intercession, and some of Miss Connor's students had a different method, and so I want to show us that, just in case we've been struggling. See if there's anything that this might help us with. In order to factor, this is what's called the diamond method. What we're looking for is we're looking for a number to go on top of our diamond, which is the first number. If this is in standard form, it's our a in front of x squared, times our last number, our c at the end. And if I take a times c in this problem right here, I get the answer of 75. 15 times 5 is 75. The bottom number is going to be our b, our last number that's in this problem, the number that's right in front of the x. And in order to factor by using this method, since I combined together a and c in the very beginning, I'm not looking for a collection of 4 numbers. I'm just looking for 2 numbers that multiply to 75 and add to negative 28. If I can find those 2 numbers, I will have factored this problem. Now, there's a lot of different possibilities of numbers that could multiply to 75. If you're not sure what your answer is going to be, what I would suggest is take 75 and write factor pairs of it. 75 could be 1 and 75, but they don't add to 28, so that doesn't work. It could be 3 and 25, and all of a sudden I find Well, 3 and 25 do add to 28, and to multiply to a positive, they both have to be the same. But if I had a negative 3 and a negative 25, those two numbers multiply to 75 and add to negative 28. So it follows this pattern that we have. Those two numbers I'm going to place in my parentheses down here. But the only thing that's different is my answers aren't 3 and 25. If they were 3 and 25, this last number would be a lot bigger. We altered our problem just a little bit. In essence, what we did is we took our C and multiplied it by 15 to find numbers that would work, and it was a little bit easier. But now that we're done, we have to go back and divide again by 15. I divide by 15 in both of these cases, and I get these weird fractions that are here. And here's how these fractions work. These fractions work by, if I can reduce this, and 3 over 15 reduces to 1 over 5. 25 over 15, if I divide top and bottom by 5, reduces to 5 over 3. The way that these work is that the top number of these fractions is going to be the actual number that goes in my parentheses on the right-hand side. So it's going to be x minus the top number is 1, x minus the top number is 5. So the top number is our factor number, we would call it, our constant term in the set of parentheses. The bottom number is actually going to be what is multiplied up front by our x. So if there's a 5 on bottom, it's 5x minus 1. If there's a 3 on bottom, it'll be 3x and then minus your 5. And that will give me my sets of parentheses. When you're doing this, because this is new, I do want you to go back and check your work. Multiply the first two, do they get to 15? Multiply your last two, does it get to 5? Do the outside-inside operation just to make sure it works. But this method is helpful if writing down all these possibilities gets a little bit cumbersome for you. In the end, if I'm solving both of these for x, I'm going to end up getting x is 1/5 and x is 5/3. And so these two fractions actually do become my two answers. It's the opposite of my parentheses again, so it's a negative turns into a positive. But it's just like over here, when I had 5 over 2, that was there because the 5 was by itself and the 2 is with the x. Here, if I have 1 over 5, my answer is, well, the 1 is by itself, the 5 is with the x. And so the denominator comes from the x value in this example here. I'm going to show us one more so that we can just try to solidify this a little bit. And then if you want to try the diamond method, do a couple of problems by factoring it that way, and then make sure you check your work because this is a new option, new method. For this last example, we want to look at what number goes on top, and that's first times last. And 8 times 15 is going to be 3120. On the bottom, we're going to have 26. And so we look at this, and there's a lot of possibilities for numbers that could multiply to 120. When we start looking at these sorts of problems, what makes the diamond method a little bit more difficult is that we're going to end up with some larger numbers. What's nice about this is if we write down this list, one of those possibilities will work. And it actually ends up being the combination of 20 and 6. 20 and 6 multiply to 20. And they add to 26, and so that gives us the two numbers to put in our parentheses, plus 20 and plus 6. They're both pluses because they're both positive. If this was positive and negative, you would do x plus 20 and x minus 6. And then because we multiplied by 8 at the beginning, we have to divide by 8 now. We reduce the fractions, and that turns it into x plus 5 over 2 and x plus 3 over 4. That means that my two parentheses are going to end up being 2x plus 5. The denominator goes in front of the x. And 4x plus 3. The 4 goes in front of the x. And if I solve and actually find my zeros, my answers are negative 5 over 2 and negative 3 over 4. the opposite of my parentheses, but it also works if I solve it by using my previous method there. It's a little bit hard to see. I'm going to scroll over just a bit so you can see all of it. Once again, the numbers that we have, 20 and 6, multiply to 120, add to 26. We put them inside of our parentheses and divide by 8 because we multiplied that in the beginning. And our fractions end up being the answers. Our fractions are also where I take the denominator and put it up front, and that gives me my 2 actual factors. My final answers for these are going to be my factors after I've moved the denominator to the front, and then my zeros are going to be the x equals answers. I know there's a lot of different places, a lot of different steps in this, but these are the 2 final things that we're looking for in these problems, and this is how we factor by using the diamond method.